I guess now the mic's turning on. I see people still coming in, so let's wait for a small minute for people to coming in. So take your time, no rush. We got a whole hour to spare, so anyway, I'm so glad to see you here. And I do think that 10:20 is still an early hour for me being not a morning person, so thank you so much for being here. And no worries, no physical activity, no weird sportiness to keep you awake. I'm not awake either, so no worries about that. So I see some more people coming in. Or not, I guess. Then we are about to start. So official good morning, everyone. I'm so happy to have you here in my session for NDC Security, especially as it combines testing and security, which are two really important topics, but maybe not the perfect topic for a morning after a party, fueled, whatever you want to call it. Anyway, I'm so happy to have you with me to bring you on a little journey. But before I start, I want to ask you a small question. Please raise your hand if you either see the reference inside of my title, in the style of it, or if you recognize this little fella, which will help me get through the journey. Oh, I see some hands raised, which makes me a little less nervous because I know I got fellow nerds with me who loves to play games. Maybe did a mobile game as I did, because this is a reference to Plants vs. Zombies. And this is a tower defense game, actually. It filled my, I'll put it here. It filled my bus rides to school with some joy, some cuteness, some nerdiness. It was basically a game published by the studio called PopCap in 29, as far as I remember. So it was a cross-platform game. I don't know if it was a cross-platform game from the start, but as I played it on my mobile phone, it is a tower defense for the people who don't know what Plants vs. Zombie is about. Tower defense means we try to protect something precious, obviously, sometimes a home base, against attackers, which might be an army, might be something, might be zombies. Yes, if you might have guessed from the title, it's trying to protect one's own against a zombie apocalypse. And we got wonderful weapons under our belt. Loads of plants. And yeah, I love playing it in my youth. And this is nice and all. It's wonderful nostalgia for some people and maybe interesting to know for others who are not into gaming. But you might rightfully ask me, what's it? What does it have to do with web development? What does this have to do with NDC security? And this is a rightfully so question. Well, let me answer that. What if I told you if it's a wonderful allegory on security, because we want to protect something special, something precious to us, right? And for me, being a developer advocate, but I've been a front-end developer beforehand, and before becoming a front-end developer, I've been a test engineer. I just love this allegory, because it's wonderful for testing as well. See this little guy? So this plushie is actually a character from the game. It's called Potato Mine because it should be a potato. I guess with lots of fantasy you can see that. And if you step onto it, it does things what mines always do, like exploding. So if an attacker in our application steps to a test, it will be exploding. And of course the test will not be destroyed, of course not. But I guess it's a wonderful metaphor on a good messenger, right? So a test will make you aware of issues, and it will make you aware of security issues. To shed more light on the metaphor of Plants vs. Zombies and web security, let's put it like that. So the zombie actually, it's a threat. It wants to eat our brains. We don't want to be eaten, right? Or in terms of an application, we don't want our application to be exploited, data to be stolen, people accessing features they are not paying, stuff like that. So it's a wonderful allegory on threats. Same, our plants, like the pea shooter here, are all representative of all countermeasures, like the potato mine, like this pea shooter shooting peas. It's all things we can use as a mitigation strategy. Might be tests, might be tools, might be best practices we implement into our application. So yes, if we zoom a little out, we can see the playing field, which is basically our or yard, or foreyard, or however it's called in English. So our house here would be representative of the application we have, or basically anything precious in it. As said, sensitive data, protected features, stuff like that. The whole playing field is the application, and the gardens are our defenses, such in the game where you try to plant your plants inside of this garden. Maybe a little bit more to the front, maybe closer to your house, but every mitigation strategy, every defense, you have to protect yourself against zombies or attackers. It's the same in this regard. Yeah, and automated tests, as said, like this potato mine here, can be a countermeasure of your garden. And I want to present another point of view, because obviously there are loads of wonderful tools out there, help you scan your application, help you get notified in case there are any issues. But did you consider using your vanilla testing frameworks? Like the tools you already have. A small question to the room, how many people of you already write tests? Oh, this is a lot of people, I'm so relieved to see that. How many people of you guys are writing front-end tests? Oh, it's another bigger number of hands. I'm happy to see that. So maybe it's a good idea to consider using your typical tools you already use for writing tests to capture security issues, right? And generally, we just need to learn where to look to write the right or correct test and get the correct message, get the correct messenger in place. And of course, this might spark a question which is completely valid. If there are any security tools, external tools, why should we write our own tests? Because those solutions are doing a wonderful job, right? Well, this is a small teaser for the main question of this talk, and after this hour, I hope I give a wonderful answer to you, or at least guide you on how to get a wonderful answer for yourself. But just to give a small spoiler, it's not just a typical write test because it helps you save your ass. Sorry for those words, but it's more on it. Okay, so before I say why it's a good idea to write vanilla tests for security issues, let's take a look what I actually want to do, right? What's my game plan? How can I beat the zombie apocalypse in Plants vs. Zombies? Or in other words, how can I protect my application using vanilla test cases, vanilla testing security stuff and tools? Trying to counter the question like, what if I don't want to learn new external tools, or I don't want to spend more money on external tools? Or battle plan, basically, against zombies. So they will hopefully run away really fast and don't try. Okay, first and foremost, which is basically general advice, I think you need to learn your application. You try to get to know your risk, the vectors, which might be interesting for your front end. May it be an injection, which might happen. May it be your infrastructure, which is not completely resilient yet. So try to learn your application. Try to include the requirements the stakeholder have, and try to learn where an attacker might enter, like here, through the garden, later from the street, stuff like that. So I'm happy you already did the first step by visiting NDC Security, because it shows you learn new things. You learn new angles. You try to get better in building secure applications. So you already did the first part. And for the rest, we're here. Especially when it comes to the next starting question after, like, what's a better plan? Where do we start? In Plants vs. Zombie, for example, there's often those sunflower plants which generate energy, so it's often the first thing to do. What does that mean for security testing using vanilla tools? Where do I start automating? And this is a wonderful question, because I can use my QA lens, being a former test engineer, and my dev's perspective. So, at first, I tried to come up with a first draft of priorities, which says what needs to be covered first. And in this regard, I try to ask questions similar as I do when it comes to normal test automation, like, okay, what are the most common used features? Where would be an error which I would recognize pretty quickly? And it would be bad if the customer is noticing it before I do, right? What would cause most damage when broken? And Then I will try to take a look at some knowledge which is out there, being at conferences, for example, or on the internet, which we cover later on. But yes, I try to come up with a first sense of prioritization, and then I will refine it by taking a look at risk level. It's basically a risk analysis, which I would love to do as a test engineer. So trying to identify and analysis of potential issues that could negatively impact key features or key things. Like, where's the law? Which do I need to adhere? Again, what's the most damage, or where do we cause the most damage when broken? And then I try to refine this priority. Next question. How much time and thus how much money would it cost me to automate this thing? If I use my vanilla testing tools, my spoiler, it wouldn't cost me that much money because I already know my tools, right? And if I don't do testing, it's easy to learn it because there are lots of resources out here. I did some talks on it as well. If you're interested, I can show them later on, or at least refer you to the links. And yes, how difficult would it be and how much money would it cost me to automate or write those test cases? And last but not least, consider business value. Take the requirements of your stakeholders and basically adjust your priorities if you need to a little bit. It shouldn't be the basis of your priorities though. In case of finding the first draft of priorities or accessing risk, there are resources to help us, guide us. And I guess you mostly know this logo. OWASP helps us with us to find the first test cases we need to cover. Just to get us all on the same page, I will quickly repeat what OWASP is. Doesn't take that much time, so no worries about that. It's a shorthand for an open worldwide application security project, and their goal is to raise the security in web. And they have lots of resources, lots of recommendations, but also they are, I'm a little too fast, sorry. They are releasing a ranking all few years. And as far as I know, last time I checked, they are at data collection. At least they have been collecting data last month. So I guess they are not at the normalization stage yet. So there's a new ranking upcoming, but I don't know when. So for this talk, I will use the second up-to-date information, which is 2021. And there I will take a look at the top 3, because from a front-end lens, which I have as a former front-end developer, these are the most important ones. And especially one is really important and pretty easy to cover with test automation. So yes. To rehearse it pretty fast, it's top 3. The first is broken access control. So all staff users can outside their given permissions. Cryptographic failure, so if your encryption fails because of those requirements are not met. And last but not least, the most important point for front-end developers, injections. Attacker who can supply untrusted input to a program and it will be compiled as our own, which is pretty bad, right? So knowing those causes, knowing those risks, having our own priorities in place, how do we get to execute then? How do we cover our garden? I like the word cover here because it refers to test coverage, which we try to achieve without testing every little input field or every little route. Especially as I want to use a particular way of testing, I will show it to you later on, mimicking an attacker pretty good. However, it will take some execution time. So how do we invest in flowers, in plants, in mitigation strategies from a test automation perspective without being not that reasonable when it comes to time and money? So the plans. Our plans, it's the same in web security and in Plants vs. Zombies, are our lines of defense. We want to have a great garden with a variety of flowers to have great coverage and use bare metal testing code. So not only those potato mines, right? If you have a minefield alone, you might have problems with zombies flying. There are actually zombies flying with a balloon. So yes, we need to have diversity in it. And before to see what kinds of plants we need for a garden or application, let's take a look back to the playing field. The attackers will arrive from the street. So where can we put our flowers or plants? Because different plants are stronger in different parts of the garden. Like the front-facing one, which is obviously the front end. the part of the application which is first being visited by attackers, because like it's a big vector people see, especially if they're doing scripts. The mid part, the API testing part, which is obviously interesting for integration tests, but also end-to-end, small spoiler. Back-facing one for backend, which I will not focus on that much as a front-end developer, but I guess there's loads of content here at the conference helping you guys. And last but not least, the house, the infrastructure. Your application itself and your infrastructure itself needs to be resilient as well. In Plants vs. Zombie terms, is it made of bricks or wood? As a front-end dev, we will go for basically API and front-end layer here. And the first and I guess most obvious answer on how to write security tests without using that many third-party tools is writing conscious and intentional test cases, or logical test cases, as some people would say. So, as our test is a messenger, we want to be notified if there's an issue. And I went for this walnut plant, which is basically a plant in the game, trying to make it a little more difficult for a zombie to pass through them, so without us noticing them. It's not the perfect allegory for those tests, but I guess you get the point. We want to be notified. And to have a wonderful, realistic notifier, we will use end-to-end testing for this. So I like to use this way because it tests your application from beginning to end, implying that we have the full tech stack or application stack present, which will give us more potential spot to search for issues and a more natural way because it mimics an attacker, right? In this case, I will use Cypress as an example, but please, please, please don't feel limited to that. I'm using Cypress because it's well suited for presentations. You will see in a bit because of the test runner. But you can go for Playwright, Selenium if you're brave enough, or for Test Cafe, for whatever tool you use. Retest, there are loads of tools. I will try to be as agnostic as possible, even though it's not always possible, but I try my best. So, injection is most well suited to be covered by tests, because it's easy to reproduce with end-to-end testing. Of course, we'll have attack angle where people will inject code. You can do this by using E2E tests pretty easily, because you can basically make the test type stuff into your input fields. When it comes to the kind of test I want to write as an end-to-end test, I will go for negative tests. Negative tests are basically tests watching for expected error behavior. So basically going in variety, what happens if I basically use invalid credentials inside of a login form? I want to have an error message. What does happen if I use like special characters? I want them to be escaped or filtered out. So those tests watching for intended behavior resulting in an error are called negative tests. And I do think these are important and wonderful, well suited to be our bare metal vanilla test cases for security issues. And of course, by writing them on our own, we will learn what other external testing tools are basically doing under the hood. For example, Zap is doing exactly that. So let's take get our hands on code, actually. I want to write those test cases together with you in a little bit, but just to get you some context, we will need to have a test basis, so we need to have a broken shop. And to not being embarrassed on the stage, I will not use my own broken shops. And of course, I don't want to rent to other people's applications. So there's one, which is pretty good and well suited for demos and training, and it's Overjuice. So of course, the test we will write together will fail because this shop is broken by purpose. There will be security issues, but I want to prove to you that those test cases we will write will be able to detect security issues. So I guess Overjuice is a wonderful idea to use. I will use the Docker image to don't cause any harm anywhere else. And many tests are at least referring to Over's challenges, so the ways on how to learn how to attack this shop, or actually solving those challenges by doing those tests. So you can find those on their page, and you can see that you were able to solve the challenges by your test by visiting their scoreboard. Okay, so let's get on to code. I used a little folder, standard stuff, to create a project, and then I use npm install to get Cypress running. You can go for yarn, pnpm, or even download their zip file if it's more convenient for you. Yeah, let's wait for a little longer to download the internet because npm is doing npm things, of course. I guess we're ready to open Cypress. There are a couple of ways to interact with Cypress. I'm going by npx because it's easy to display on a presentation, but you can have own scripts in it. You can do it headlessly. I want to have the test runner to showcase the test so we can actually see Cypress clicking through the application in a bit. So for doing this, we will use the wizard. It will create all configuration we need and scaffold a first example test. I call it in SQL injection. Small spoiler, this will be our first test we will write together. And it's not this, like we will do more than just going for the example page, so no worries. In case you didn't work with Cypress before, a small rewind of how those tests look like. So you can see this describe block here, and my laser is not working. It is. So it's Mocha syntax. So if you are familiar with Jest, for example, you already saw it at some point. This describe function is the frame. I like to call it frame, but it's basically the test suite, which is there to organize your test, make it easier to interact with them by running them in a batch or using lifecycle hooks. And this it part here is the test itself. So there most of the magic will happen in this talk as well. Okay. If you want to refer back to my tests I will write in a bit, there's a sample repository. I leave it open for a little minute, but don't be worried. I will post my slides later after this talk. So if you don't get this QR code or QR codes to other resources, you can basically refer back to it at any time. Or you visit me at the booth, so I can show it to you in person. Okay, so a demo that is insecure by design. How does such a test look like? I will cover the SQL injection a little bit more in detail to let you see how to write those tests. But the other one will be inside of a demo as well. So let's write it. First, we want to get to the login form, right? So I want to get the menu item, the selector to it, so we can make Cypress click it. The test runner will help us get the selector. I will copy it here, get back, and paste it because the Cypress test runner helps us with that. I want to make sure it's rendered completely so we are able to interact with this button. It's really important to avoid flakiness because if an element is not loaded, we cannot click it. So you will see this is visible assertion a lot. After actually clicking the menu item, we want to have the login menu item as well. So we basically do the same as we did before. Interestingly, the overview has many IDs, which makes it a little easier to have readable testing code, which is great. So let's check if it's visible so we can interact with it, it's rendered, and then click it. And hopefully we are getting to the login form now in our test. Let's validate it, because I was saving, it was already re-executed, and we can see the login form. I will get the selector of the login form to make sure it's loaded before we try to type into this form. Again, to avoid flakiness. Again, with our everyone's favorite assertion should be visible. And then we should be able to finally type into those form input fields. And I will use the email one for a small SQL injection. This one should be giving us the first user from the database because it will be compiled into a full-blown query. But you can go by any SQL injection you want to try out. Maybe this is, to spoil a little bit, a good angle to get some randomization in later on. So let's go for this simple one. And then it basically doesn't make any difference what password we choose for, as you already know, I guess. So yeah, let's type the password input field. I should type a little faster, I know. But we still got some time left, so it's fine. So we will type whatever because it doesn't matter what password we use. And then we will need to submit the form. I will refer back to the login form because I remember it was disabled before we entered password and username. So let's make sure it's enabled before we click it, otherwise the test would fail. So let's go there, say should be enabled, and then we should be able to click. A good thing in Cypress is it chains those commands, so it will wait for every command to be executed before going to the next, which helps us avoiding flakiness as well. So yes, let's take a look. We'll click it. And hopefully, okay, I will still take a look what happens if we have invalid credentials, because this is actually the expectation we have when it comes to a normal application. It shouldn't log in, right? So let's go for this error message. Remember, negative test. And assert that this error message exists after trying to basically invalidly log in. So the error should be visible and the page should contain the error message we copied before. Spoiler alert, I have a feeling this test will fail. Possibly. Could be. Well, let's see, let me type and then let's see. And oh, I have a typo in it. I need to correct the typo, of course. It's contains, not contains, obviously. Try it again. And yeah, Cypress cannot find an error on this page because obviously we are logged in. Let's see if we're really logged in. And yes, I can access the card of this user and I can see account settings. So, okay, oversteers, you might have a problem, I guess. This is a way you can cover most of ejection cases, the same with the typical cross-site scripting as well. I put it into a code snippet because the test will be pretty similar to the one we have before. Actually, I will try to go for the input field, search field in this regard, enter a small script, could be an iframe, could be a normal script, whatever you want to, and then try to find out if there's an alert popping up. So basically, if the script I put in is executed and not escaped. I'm using a Cypress spy because I can spy on functions that way, which means I can see if it's called. So this assertion here will help me to see if it's not called. In other words, it would be called. But you don't need to feel limited to cross-site scripting and negative tests because Cypress helps you do API testing as well. As far as I know, it's the same with Playwright, so loads of end-to-end test framework help you with that one. And if I have API testing at my hands, it might be a good idea to check for CSP headers. So CSP, what is like trusted sources for content allowed to load, might be a good idea to utilize our bare metal testing framework for this as well. So let's take a look how I'm doing that. So this is basically based on the first test we already wrote. So I will have some boilerplate in place. Same, I forgot to tell you about same with the cookie command trying to handle all cookie information stuff in Europe before it gets onto our nerves. So here we are using the Cypress request command, which handles all API testing in Cypress. Because we're listening for headers, we will go for the homepage because we want to keep it simple. And then I want to work on the response by using this then of the Cypress chain. So we can basically work, having the Cypress chain means we can work on the output of the command before, so I can work on the request. Before I assert on anything important, I want to do one assertion first. I want to make sure I have a CSP header in place, because otherwise why should I check for configs and stuff if I'm not sure if I already have a header, right? So let's see if our headers have a content security policy in it, so have the property. And afterwards, I will save the header to have it a little more simple, readable, stuff like that, and add some more config assertions to say it like that. So I want to see if the default source is self, because we are trusting the things we do, hopefully. So we will check if it's included here, yes. So we go for expect the CSP header to include in a bit the default source. And afterwards, I want to look for things which should not be included, just to make sure we don't screw up any config when it comes to the CSP headers. So let's go for the default source here, which should say go to self. This is okay, but it's not okay to go for other things. Let me add the not to basically turn around the assertions. I want to have it not including any, so the star, and some unsafe stuff like unsafe eval or unsafe inline. Okay, let's see if this test, which I theoretically wrote, is actually catching the things we want to. So does overviews deliver or not? You might have guessed it, but let's take a look. We will open the test. And yes, it fails because there's no header. Let's see if there's really no header in it. So I will pin the request point, and this is cool at the test runner because it gives you all information you need inside of the console. Let's zoom in. Take a look at yielded and then the headers. And I guess I cannot find it there, right? But I will filter just in case I overlooked anything. Content, security, policy. And I guess I should not switch in between US and German layout and keywords that often. But yes, I cannot find it here. So I guess overviews let us hanging in this regard as well. So far for injection, I want to take a look at broken access control as well, because it's the most important point in OWASP ranking. I would say it will stay like that for the new iteration, but we'll see. And there's some stuff to do from a front-end lens as well. Even though it's often a backend topic, we front-end devs can support backend developers as well. So, again, going for a negative test is pretty easy. We just want to cover test cases to mimic a user with insufficient permissions, trying to access things they shouldn't or try to do things they shouldn't. Yeah, and there's one challenge in overviews where you try to access the admin panel. And I guess this is a wonderful example to put into a test because it's fast. So let's take a look. Again, pretty much the same test as we had before. It's pretty simple, and then we try to visit, so navigate to the admin panel. And we guess it, because it could be administration, but attacker will guess URLs as well. So maybe, probably, because I know the challenge we are right, but yes. And then we try to see if something gets loaded, so if the page exists. And then hopefully we will get into any error message. Might be you're not allowed to access this page, or a 403 error or something. But I make sure it's actually the error message. So let's take a look onto our local browser, and yeah, there's the error message we will use. So let's change that and run the test. Great. So let's go for broken access control. And we were able to access the admin panel. Whoops. So we basically solved the challenge by using a test. You can use this negative test to cover some routes in your application as well. But again, same with injection. You don't need to be limited to this simple part of testing to write negative test cases. You can utilize API testing as well, for example, when it comes to CSRF issues. So basically, we try to use the test to make a user do stuff from another origin without them knowing it. And there's a Cypress command helping us with that. It's called Cypress origin, which I will type down a bit. It was added, I guess, 2 or 3 years before, so it wasn't there from the start. We could take a look at the documentation as well inside of a bit, because beforehand, Cypress only allowed you to work on one single origin, so one single domain. And this restriction was taken away. So I can go for the example.com domain, just pretending to be on it, which is pretty cool. And yes, there's the documentation of CY origin, and it will showcase that we are not basically limited to this thing. It will bypass this limitation. So it's wonderful to basically act like you're working from another origin. Let's get back to the test then. There we go. I will use this no origin and use Cypress requests to fire requests from this origin. So we go for changing the username because it's easy to showcase in a talk when it comes to screen size and stuff. And let's go for a post request. We will go for the profile root. And in the body, we will set the new username, which is totally not sus. Of course not, because we have best intentions all the time. So let's go for malicious admin. And then afterwards, using the then to work on the Cypress request result, basically. Beforehand, we should set fail on status code to false because we want to have a 400 error code, right? So we want it to fail. It's okay to be basically continuing the test if it fails. So we need to turn that off beforehand. Okay, going to the then. I will add some login in case we need to debug, like the status code and the content of the response. And then, as soon as I'm ready typing, I want to add an assertion. So I want to assert that by trying to change the username, we will get the 400 error code back. May it be, hopefully, the 403 for permission denied, or at least a bad request if it's possible, right? So yeah, let's go to basically one, like the response status should be one of 403 or 400. Please don't be a 200 of a kind, right? Well, it's overjuice. We gotta be disappointed here, so let's take a look how the test will be. So, there we go. Let's run it. And of course, there's a 200. Let's check if we have poor error handling and nothing's changed, hopefully, because sometimes people tend to use 200 for everything. Let's take a look. So I'll go to the user administration, to the profile page, and there's our malicious admin nonce has a username. So, damn it. I guess that's bad. Okay, so we found out that we can cover broken access control via tests as well. May it be negative tests or using API testing. But I guess when it comes to broken user control, access control, sorry, it's time for a wonderful shout out from my friend Kaya, because she will dive into access control later on as well this afternoon. So I'd be super happy if you visit her as well. You will learn about OpenFGA, which is an open source library to have access control. It's I guess, owned by the CNCF, so that's pretty cool, and inspired by Google Zanzibar. So take a look at it, take a look at her talk. I hope to see you there, or if you got questions like throughout the day, visit us at our booth. Back to the show, back to testing. I will swiftly cover cryptographic failures as well, just a little bit because it's more a back-end topic. However, if you use bare metal testing frameworks, you already are covered when it comes to encryption, because Cypress will error anytime you attempt to navigate back to an unencrypted page, to an HTTP site, which is pretty cool, right? So Cypress has us covered as well, and other testing frameworks have some limitations, helping you having failed tests if you screw up this. Of course, if you're working locally, this is not that much of an issue, but if you write Cypress tests for a staging machine, for example, this might come in handy. Okay, some general advice. Leaving the test case frame is, I guess nobody of us likes to have test suites lasting for like a day to be executed, right? I don't think it's a good idea to cover every single input field you have, every single root, using every query imaginable to have an SQL injection, same with scripts, same with anything. So we should take a look at randomization when it comes to our tests, when it comes to our test data and the inputs we have. And yeah, we should try to not test all field rules. There are a couple of things to support you in this regard. First, you could think about misusing the Cypress fixtures feature. Normally, it's like a file management to have test data in place. However, you can define JSON files in it as well. So you could use it to store routes. You could store it for single selectors of your input fields. You can use it for all kinds of things. So maybe misuse it and work on the things the fixtures feature will return you inside of your test. So pick some random route, pick some random input field. Cypress fixture feature might be already enough for that, but if it's not enough, you could think about helpers. Our dear friend Gleb Mahmutov, who's writing loads of content and plugins to support the Cypress ecosystem, has a wonderful guide on how to have like random elements, how to use random elements inside of your test, and some ideas on helpers. So that might be a good idea to include inside of your test as well, maybe as a custom command actually. Another thing by Bahmutov is the Cypress map plugin, which will help you a lot if you don't want to write this logic on your own. The Cypress map plugin has an interesting command called Cypress sample, and it's basically there for a sample of a collection of elements. So it will just return any element, which helps you in randomizing the input fields you want to test inside of your application. And last but not least, if you want to have some variety inside of your test data and try to recreate samples leading to issues, you might think about Faker.js libraries or other fakers. There are a couple of those. So these are the easy ways on how to handle this. Another way, which needs a little more deep dive into API testing, so I only touch upon that because we have a limited time frame today, is using your API schema to extract all the rules and then trying to randomize the rules you pick for testing these API test cases. There's a great learning path in a blog article, despite old, by Cypress, so I guess it's best to take a look at their docs because they will teach you all the basics. All right. These are loads of information and advice being at the test level, at the coding level, things you can implement in your daily doing. But however, I wonder how well does it fit into our Plants and Zombies life, or in developer terms, into our life cycle. So how do I integrate all those wonderful vanilla test cases into my daily doing? Let's picture a simplified way of developing. And of course, I know that the development phase and the testing phase might be swapped because it's TDD. I like TDD in some cases, but in some other cases not. So let's stay simple. Let's say we are developing a feature, implementing a fix, stuff like that, then testing it, putting it onto staging, and then to production. And if I want to integrate some test steps in it, while developing, it might be a good idea to dive into some tools. So I will phase tools in, external tools here too, but I don't want to be too fast right now. So creating a pre-commit hook to keep me away from like blatant obvious syntax or security issues. So like having linkers in place. SaaS tools might help me as well, like the static application security testing tools, when it comes to developing on my own. The testing phase, obviously, this is the point where we at latest, right, or build in test cases. So the wonderful negative or API tests we got to know beforehand. And of course, the dynamic application security testing tools or the interactive ones are well suited for this regard as well. Like the black box testing or scans you have from dynamic tools, or the basically companions you get when it comes to interactive tools. And of course, when it comes to the staging phase, you have your deployment gates and pen testing, as well as monitoring in production to get a good situation, a good view on the security status at hand of your application in runtime. Okay, this was really quick because of the time frame. There's a wonderful guide by Ovas diving into the complete world of web security testing, not only tailored to test automation. So if you're interested in learning more, there's a QR code. And of course, you can find all the things inside of my slides and inside of the code sample as well. So I add all those resources inside of the README. Okay. A point which I touched upon when it comes to testing framework selection, I want to stress here as well. It's really important to know, even though I used end-to-end testing as my prime example today, due to the limited time frame, we don't want to sit here for like hours. And end-to-end testing is actually the part I have best expertise in, just because I've been a test engineer before. You don't need to feel limited to that, so please don't think just because I used end-to-end testing here, you should only use end-to-end testing as well. There's wonderful ways on utilizing unit tests, integration tests, component tests, contract tests, whatever tests you can think of, doing exactly the same things I did today or even more. So, for example, API testing, if you don't need the complete application stack, try to think about integrating it into integration tests as well, especially as you might use them for API cases anyway, right? So please don't feel limited to that. And especially considering one certain testing type, it would be even harmful to use end-to-end testing because of the longer execution times. I'm talking about property-based testing. And again, I can only touch briefly on this topic. If you're interested to see it in the talk, please let me know, because this is a really interesting topic, but a little too much for today. Property-based testing is basically defining a set of properties or rules your system and thus your input, data input, test data input, should always follow. So you basically generate input or test data by using property-based testing, which fulfills these properties. And it gives you a whole test data set of randomized input. So if you are thinking about security-related properties, like injection-related properties, to use as a property for this input data, you might be able to get even more randomization into your test suite, which is pretty cool, right? And as said, I do think it's well suited for a unit, maybe a little integration testing, but especially as you get such a large set of randomized data, it might be a really bad idea to use end-to-end testing for that, right? You cannot wait a week for your execution, I think. There are two tools you could take a look at. The most recent one being FastCheck, but JS Verify is a good idea as well. But as far as I know, I guess it's a little older and the last contributions were a little bit in the past, so maybe FastCheck is a better idea. All right, so I phased in some external security tools, despite this being a talk on vanilla testing frameworks, right? Because I guess it's still not a good idea to waive tool support. We just need to be mindful when to use it and when not, because there's still one big danger we have. It's the complete unknown security issue. And we cannot just spend all of our days stalking CVE databases, right? So how do we handle the complete unknown threat if we cannot have any ideas? And for testing, I love to go for security testing tools like, I guess I'm a little fast, yes. For that. So that attack proxy is a wonderful idea to integrate to given testing frameworks as well. There's a sample implementation of Cypress and ZAP. However, again, I guess it wasn't maintained for a year or so, so I'd be a little careful when it comes to directly implementing it. However, it serves as a wonderful example on how to implement ZAP as a proxy in Cypress. And it's open source, so I try to limit myself to open source tool when it comes to recommendation today. Check it out. It's the prime example on how to implement it for Playwright as well. And I guess there are more implementations, especially for Selenium. So this is a good idea to use. OWASP themselves have recommendations in place as well when it comes to open source tools, or at least when it comes to community edition if there aren't any open source tools. For example, for SaaS tools, which can happen inside of your IDE being linters, you could take a look at everything GitHub or GitLab is already providing you. And personally, I had good experience when it comes to PHP Stan or Salm. That as our Dust tool, obviously. But it's a little difficult to find open source tools for iOS tools as well. I guess there's one community edition by Contrast, which is recommended by OWASP as well, but I guess we have a harder time finding interactive security testing tools for open source. But last but not least, it's a good idea to go for static code quality analysis as well. And I cannot stress that enough, keeping your dependencies up to date. There are a couple of easy commands you can include in the test scripts you write, like npm audit, which will ask for a report of known vulnerabilities, or npm outdated, checking for outdated packages. If they find something worrisome, you could write a script to let your pipeline fail, maybe. So, let's get back to the question we asked at the start. Why do I mind vanilla security test cases? Why don't I just directly use SLAP or other tools and just let it that? Well, there are a couple of ideas. As said, tests are the wonderful messenger, and a messenger you can get into your application pretty easily. It's not only saving money because you already got those tools in place. It's not only a less of a learning curve because you already got the knowledge. It's a great messenger. But of course, with being a great messenger, there's a caveat I guess I don't need to tell you, but just to make it clear, it's only a messenger. It's a wonderful messenger. However, it will not fix your issues. This is something you need to do on your own. It will only tell you that there's something to fix. I'm a big fan of having regression tests as well. So if a security issue happened at some point because a contractor or a team member wasn't that mindful when it comes to security, write a regression test so it will never happen again. You cannot just think that everyone knows exactly as much as you do. So this will prevent you from having the same issues popping up ever and ever and ever again, and thus building trust. I think that tests are a wonderful way of building trust inside of your application, and especially end-to-end testing, mimicking a user, build loads of trust. So try to think about it like that. I love to use the test runner itself because you saw it's pretty visual. You can use it to recreate the issues, to help people with reproducing. Or if you take a look at Playwright, they have a tracer, which is basically a dump snapshot of the application at the point of failure. So this will help you a lot of writing your security ticket, help people recreate the issue you found. And last but not least, I don't like using tools without knowing what they actually do. So writing those tests by yourself will help you learn that. And especially if it's like easy test cases, it will help you get a good grip on what tool's doing. All right, all of those measures combined, I do think that tests are a great complement to keep your app secure. They're the perfect messenger, and together with building your app in a secure way, adhering to best practices, having CVEs in mind, and basically using everything you learned at NDC Security, I think that it's really difficult for the zombies here to just jump over our tests or our defenses. They have a hard time to exploit your application, and even if your app is just a little more resilient, a little more hardened than others, maybe our attacker will take a look at other applications instead, right? I just hope that our application looks like this in game time at some point. Many different defenses. May it be your best practices, may it be your own skills, may it be tests, may it be external tools. Having a diverse, different defenses garden, complete variety, keeping attackers at bay and letting us sleep at night a little calmer. If there are 4 things I want you to remember from this talk, it's those. Test automation is a wonderful complement, so you should always invest in it. And in this regard, it doesn't matter if you prefer tools or prefer vanilla ones. I prefer vanilla ones. I hope I was able to bring you onto the journey when it comes to vanilla, but consider automation in any case. Try to have intentional test cases, maybe negative ones, maybe API testing, as a low-hanging fruit, because as we talked about the cost of automation, it will not take you lots of time. It will not take that much money because it won't take lots of time or learning curve. It's a low-hanging fruit you should utilize. Why not? It will not hurt. Combine your own test cases to the external tools at hand, because this way you will cover both known angles, known vectors, and unknown threats. And last but not least, utilize all testing types, including property-based testing, to have good randomization, have good execution times without spending too much money on waiting. Okay. What's else left to say then? Thank you so much more for being here. It was a wonderful journey together with you all. My name is Ramona Schwering. I'm working as a developer advocate at Auth0. Meet me at the booth if you got questions, or just ask them here in the room. I'm basically present on all important platforms in social media under the handle Lichteckig. And yeah, get to know my favorite project, which is a component library. Talk to me, ask me questions. I'm happy to talk with you here in Oslo. Thank you so much.